In this particular section, we're going to be discussing some prerequisite topics that you will need later on when we actually get into some of the calculus units. So here what we wanted to discuss is the slope of a line passing through 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. These are subscripts, so this is read x sub 2, y sub 2. And the slope, m, is what we use to designate the slope, the letter m, is equal to y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Now you'll also see this written in your textbook as y sub 2 minus y sub 1 and x sub 2 minus x sub 1. Either way, it will give you the same answer. But if you begin with y sub 1 upstairs here, then x sub 1 would have to go in the corresponding position downstairs. And likewise, if you begin with y sub 2 here, then this would have to read x sub 2. Either way, you'll get the same answer. The key thing here is to remember that in computing the slope is the change in the y's over the change in the x's. This is a little Greek symbol that is called delta, and it means change of. But it's the change in the y's over the change of the x's. One of the most common mistakes that students make is they like to compute the change in the x's upstairs, and that's not correct because the slope is the change of the y's over the change in the x's. So here we want to find the slope of the line passing through negative 2, negative 1. So what I would do is I would come under one of these, and I would simply designate one as x sub 1, y sub 1, and I would designate the other as x sub 2, y sub 2. So that way, when I substitute into the formula, I'm less likely to make a mistake. So my formula, I want to find y sub 1, which is a negative 1, subtract, which comes from the formula, the symbol here, y sub 2, which is 3, all over x sub 1, which is a negative 2, subtract x sub 2, which is 4. So this is y sub 1 minus y sub 2, x sub 1 minus x sub 2, which gives me a negative 4 over a negative 6, which is equal to a positive 2/3. So that is the slope. Now remember again that the slope represents the change in the y's. So how do I get from y equal to a negative 1 to y here, which is equal to 3? Well, I'd go up 1 unit, and I would be at the point of origin, and then I would have to go up 3 more units, and if you're going up, then you're going in a positive direction, so that is positive 4. So the change in the y's is positive 4, and the change in the x's, well, how do I get from x equal negative 2 to x equal to 4? Well, this is x equal negative 2, so I move over here 1 unit, I'm at negative 1. Move another unit, I'm on the y-axis, so that's 2. And then I still have to go 4 more units, so moving to the right, so that's a positive 6. So it's a positive 4 over positive 6, which is still positive 2/3. If you move up or to the right, then you're moving in a positive direction. If you move down or to the left, you're moving in a negative direction. So if I were going to go from this point to this point, I would be moving to the left negative 6 units and down negative 4 units, which still gives me change in the y's. Remember, change in y's over the change of the x's. That would be equal to negative 4 over negative 6, which would be equal to 2/3. But again, the important thing to remember is the slope is equal to the change in the y's over the change in the x's. A couple more things I want you to remember about the slope of a line. A horizontal line has slope equal to 0. A horizontal line has slope equal to 0. For example, if we were to plot the coordinates that I have given you here, they are negative 6, positive 4, which is this point, and positive 2, positive 4. So this is a horizontal line. And according to what I've given you here, the horizontal line has slope equal to 0. So let's designate this as x sub 1, y sub 1. And this one as x sub 2, y sub 2. And let's compute the slope. So the slope m would be equal to y sub 1, which is 4, minus y sub 2, which is 4, all over x sub 1, which is negative 6, subtract x sub 2, which is 2, which is 0 over negative 8, which is equal to 0. So a horizontal line has slope equal to 0. A vertical line has no slope, which means that the slope is undefined. So let's look at the difference between 0 slope and no slope. A horizontal line does have a slope, and it's equal to 0. But a vertical line does not have a slope. It has no slope, meaning the slope is undefined. So let's designate this as x sub 1, y sub 1. And let's designate this as x sub 2, y sub 2. And let's compute the slope. So the slope is equal to y sub 1, which is 6, minus y sub 2, which is a negative 8. Be careful here. This is a subtraction symbol, which comes from the formula m is equal to y sub 1 minus y sub 2 over x sub 1 minus x sub 2. So this is a subtraction symbol, which comes from the formula. And this is a negative sign, which comes from the fact that y sub 2 is a negative 8. So be careful with the double negatives. Over x sub 1, which is negative 2, subtract x sub 2, which is a negative 2. Again, be careful with your double negatives here. This is a subtraction symbol, which comes from the formula itself. This is a negative sign, which comes from the fact that x sub 2 is equal to negative 2. So 6 subtract negative 8 is 14, and negative 2 subtract 2 is equal to 0. You cannot divide by 0. You cannot have 0 downstairs. Division by 0 is meaningless. It is undefined. So that means that there is no slope. That is to say, the slope is undefined. Now, if we were to graph those coordinates, we'll see that we have a vertical line. We have negative 2, positive 6, which is up here somewhere, and we have negative 2, negative 8, which is here. So you see that, I missed my mark there, that this is a vertical line. And this is a horizontal line. So horizontal lines have slope of 0. Vertical lines have what we call no slope, which means that the slope is undefined. All right, now a couple of other things in reference to slope. If we look at the graph of a straight line, if that line rises as we go from left to right, then the slope is positive. If the line falls as we go from left to right, then the slope is negative. So here, as we go from left to right, this line falls. As we go from left to right, this line rises. So here the slope is positive because it rises from left to right. And here the slope is negative because it falls from left to right. And again, to reinforce what we spoke of earlier, a horizontal line has slope of 0. A vertical line has slope that is undefined. In this section, we're going to be working with slope again, but in relationship to writing the equation of a line. So the first form of the equation that we're going to talk about of a line is called the point slope. The point slope form of the equation of the line is y minus y sub 1 is equal to m, which is the slope, times the quantity x minus x sub 1. So here we want to find the equation of the line that passes through the 2 points negative 1, 2, and 3, 1. Now, in order to use the point slope form of the equation of a line, we need a point on the line. Well, we have a point on the line. In fact, we have 2 points on the line, so I could use either one of these 2 points. It doesn't matter. But we also need to find the slope of the line. And here we're given 2 points through which this line passes, but we're not given the slope. So the first thing we need to do is compute the slope. So the slope is equal to y sub 1 minus y sub 2 over x sub 1 minus x sub 2. So designate this as x sub 1, y sub 1, and this as x sub 2, y sub 2. Then substituting in, I have y sub 1, which is 2, minus y sub 2, which is 1, all over x sub 1, which is negative 1, subtract x sub 2, which is 3. So 2 minus 1 is 1. Negative 1 subtract 3 is negative 4. So my slope is negative 1/4. So now this is m. So I have the slope, and I have 2 points through which the line passes. In order to use the point slope form of the equation, I need a point on the line. Well, I have a point on the line. In fact, I have 2 points on the line and the slope. So now that I have the slope and a point on the line, then I'm going to use my point slope form of the equation and simply make some substitutions. So I have y minus y sub 1. Y sub 1 is 2. Now my choice of x sub 1 and y sub 1 was completely arbitrary. So this could be x sub 1, y sub 1 if I wish. So I could use either point. So I have y minus y sub 1, and I'm going to go with this point since I designated it as x sub 1, y sub 1, is equal to minus 1/4 times the quantity, don't forget the parentheses here, x minus x sub 1, which is a negative 1. And again, you need to be careful here because we have a double negative. This is a subtraction symbol which comes from the formula. This is a negative sign which comes from the fact that x sub 1 is negative 1. So this gives me y minus 2 is equal to negative 1/4 times, and since I have a double negative, that will give me x plus 1. Now I need to simplify this. So this is y minus 2, distribute the negative 1/4, minus 1/4 x, and a minus 1/4 times plus 1 is a minus 1/4. Now I have a real number here, a real number here, so I need to, and the x should be here at the bar or upstairs, so I need to add 2 to both sides. So this is y is equal to minus 1/4 x minus 1/4 plus 2. Now, remember in adding fractions you have to have a common denominator, so that's y is equal to minus 1/4 x minus 1/4 plus, and remember this is 2 over 1. So if I want to write this 1 as a denominator of 4, I'd have to multiply the 1 by 4, which means I also have to multiply the 2 by 4. So 2 is the same thing as 8/4. So y is equal to minus 1/4 x. A minus 1/4 plus 8/4 is a plus 7/4. So this is the equation which passes through the 2 points negative 1, negative 2, and 3, 1. Now this equation is not written what we call standard form. This is actually the slope y-intercept form, which we'll talk about a little bit later on. The standard form is ax plus by equal to c, where a, b, and c are all integers. Remember, the integers consist of 0, the positive whole numbers, and their negatives. In other words, there are no fraction, no values like negative 1/4. So if we want to write this in standard form, first of all, we're going to have to write the x and y terms on the same side of the equation. So that means we're going to have to add positive 1/4 x to both sides. So that's 1/4 x plus y, and that means the 7/4 will remain on the right side here. So what I have to do is transpose this, take this term and move it across the equal sign. Anytime I take a term and move it across the equal sign, then the sign of that particular term changes. So this goes from negative to positive. But here, a, b, and c are not integers. So what I'm going to have to do now is multiply both sides of the equation through by some number that will eliminate the 4's downstairs. So what I need to do is multiply both sides by 4. And if I multiply both sides by 4, then that will eliminate the fractional values downstairs, and a, b, and c will become all whole numbers. So 4 times 1/4, that gives me, the 4's would cancel, that gives me x. 4 times y would be 4y, and 4 times 7/4 would be 4. So this is the equation of the line that passes through these 2 points written in standard form. So this is the standard form of the equation of a line, where the coefficients and the constant term are all integers. Now, it's very easy to check this to make sure that you have the right equation, because I claim that this is the equation of the line that passes through these 2 points. In other words, these 2 points are on the line, so therefore it must satisfy this equation. So just substitute negative 1 in for x and 2 in for y, and it should work for both values. So this is negative 1 plus 4 times 2, which should equal 7, rather. I'm sorry. The 4's cancel and gives you 7. And that's negative 1 plus 8 is equal to 7. And it should also work for the other values as well. X is 3, y is 1, and 3 plus 4 is 7. Okay? So this should be a 7 here, not a 4. The 4's cancel, which gives you 7. Recall that the equation of a horizontal line is y is equal to some constant. X can be anything you want it to be, but y has to be equal to some constant. And the equation of a vertical line is x is equal to some constant. Here, y can be anything you want it to be. So now I want to find the equation that passes through these 2 points here. So first of all, I want to determine the slope. So I'm going to designate one as x sub 1, y sub 1. I'm going to designate the other as x sub 2, y sub 2. And I'm going to compute the slope, which is m is equal to y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Remember, it's the difference in the y's or the difference in the x's. So y sub 1 is negative 3. Subtract y sub 2, which is negative 3, over x sub 1, which is 2, minus x sub 2, which is a negative 4, which gives me 3 subtract a negative 3 would actually be equal to 0, and 2 subtract a negative 4 would be equal to 6, which is 0. Now, I can still use the formula y minus y sub 1 is equal to m times x minus x sub 1. Because here I do have a slope, it's just equal to 0. So that would be y minus y sub 1, which is a negative 3, is equal to 0 times the quantity x minus x sub 1, which is 2. Well, 0 times anything is 0. So that gives you 0 over on the right side. On the left side, we get y plus 3. And if I transpose this to the other side, I get y is equal to negative 3. Well, the first thing to note is once I obtain a slope of 0, then I know that this is a horizontal line. And the equation of a horizontal line is y is equal to some constant. Well, look at the y values here in these two ordered pairs. Notice they remain constant. So I really didn't have to do any of this if I note that here these two y coordinates were the same. They're constant. So the equation is y is equal to negative 3. And I also know that the equation is y is equal to negative 3 because the slope was 0. And I know a horizontal line has slope of 0. And the equation of any horizontal line will be y is equal to some constant. So all you have to do is look at the two y coordinates. Notice that they remain constant. Constant means they do not change. So the equation is y is equal to negative 3. Likewise, I'm going to find the equation of the line that passes through y sub 1, x sub 1, y sub 1, which is 6, negative 10, negative 6, negative 10, and x sub 2, y sub 2, which is negative 6, 8. So again, I'm going to use the formula. M is equal to y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Here, y sub 1 is a negative 10. Subtract y sub 2, which is 8, all over x sub 1, which is negative 6. Subtract x sub 2, which is a negative 6. So negative 10 subtract 8 is negative 18. And negative 6 subtract negative 6 is actually 0. You cannot divide by 0. Here the slope is undefined. There is no slope. Now, what kind of lines have no slope? I know that this is a vertical line. And the equation of a vertical line is x is equal to some constant. Well, that means that the x value doesn't change. It remains the same. If you look at the two x values here, notice that the two x values are the same. They're both negative 6. So the equation of this line is x is equal to negative 6. Now, if I ask you to write the equation of the line, don't just tell me that the slope is undefined, there's no slope. That's not an equation. What kind of lines have no slope? Vertical lines. What is the equation of a vertical line? X is equal to some constant. And actually, I didn't even need to do that. If I simply note that the two x coordinates are the same, then the equation of the line is x equal negative 6. Before we finish our discussion on slope, there's one more equation of the line that we want to talk about, and that's the slope y-intercept. The slope y-intercept is y is equal to mx plus b, where m is the slope and b is the y-intercept. Now, the y-intercept is the point on the x-axis, or the y-axis, I'm sorry, the y-coordinate of the point on the y-axis where the line crosses. So the y-intercept is the y-coordinate point on the y-axis where the line crosses. So any point along the y-axis has x-coordinate of 0. So the y-coordinate of the point at which it crosses the y-axis is called the y-intercept. So in this particular case, I want you to find the slope and the y-intercept for this particular equation. So what I have to do is take this equation, which is written in standard form, and write it in the slope y-intercept form. In other words, what I need to do is take that equation and solve for y. So I need to subtract 2x from both sides. And here, this is minus 6y, so I need to divide everybody through by negative 6. So that gives me y is equal to minus 1/3 x, and 10 divided by negative 6 is minus 5/3. So the slope of this line, m, is equal to negative 1/3, and the y-intercept is minus 5/3. So that means that this line is going to cross the y-axis at 0 minus 5/3. And of course that would be negative 1 2/3. So it's going to cross the y-axis somewhere in here, which is 0 negative 5/3, or 0 negative 1 2/3. And of course here the slope is negative, so that means as we go from left to right, the line is actually going to fall. In calculus a lot, we express our answers in something we call interval notation. And interval notation has to deal with how we represent inequalities. So the open interval, AB, is a set of all real numbers such that A is less than X and X is less than B, given that A is less than B. So you are familiar with open intervals from algebra. So if we want to represent 2 is less than X and X is less than 5, then that's simply all the values between 2 and 5. X represents all the values between 2 and 5, not including 2 or 5. So we use an open circle there, or parentheses around 2 or 5. Parentheses indicates that the endpoints are not included. So the 2 and 5 are not included. So in algebra, we would write this as follows. We would use an open circle around the 2, open circle around the 5. Hence, open interval, the name open interval. In calculus, however, the open circles are actually replaced with parentheses. So we put a parentheses around the 2 and around the 5. And it would include all values for x that are in between 2 and 5, but not including 2 and 5. So I'm defining the open interval AB. So in set notation, this is the way we would write it. But in interval notation, and that's the way we're going to express our answers in calculus, is using interval notation, we would say that that is the open interval 2 to 5. Now, this is not an ordered pair. In this particular notation, it doesn't represent the ordered pair 2, 5. It indicates that x is all values such that x is less than 5 but greater than 2. Now here we have what we call a closed interval. To represent a closed interval, we use brackets and not parentheses. The difference between the open interval and the closed interval is here that the endpoints are included. So the closed interval AB is a set of all ordered pairs such that A is less than or equal to X and X is less than or equal to B. So here A is part of the solution set. B is part of the solution set because X can be equal to A or B. So here is the way we'd represent an open interval where 4 is less than or equal to X and X is less than or equal to 7. That would include all values for X between 4 and 7 and including 4 and 7. So in algebra, the way we would write that is we would use a solid dot to indicate that 7 is part of the solution set, and a solid dot here to indicate that 4 is part of the solution set, and everything in between. But in calculus, what we're going to do, instead of using the solid dots, we're going to use brackets. So we're going to put a bracket around the 4 and a bracket around the 7 and shade everything in between. So the closed interval AB, and it's closed because it includes the 4 and the 7 and everything in between, is the set of all x such that x is less than or equal to b but greater than or equal to a. Now we have different variations of those intervals. We can have an interval that is half open or half closed, if you will. And here notice that we have a parenthesis around A, but a bracket around B. So that's the set of all x such that x is less than or equal to b. It includes the endpoint b, so that's why we have a bracket around it, but it does not include the endpoint a. Whereas the half open interval with a bracket around the a includes the endpoint a. So that's a is less than or equal to x, but it's parenthesis around b, so it doesn't include the endpoint b. So basically, parenthesis indicates that the endpoint is not included, whereas a bracket indicates the endpoint is included. The endpoint is included when you have an equality. The endpoint is not included when you have strictly an inequality. So what's represented here on this particular number line is -2 is not included in the solution set, but everything in between -2 and 3, including 3, is included in the solution set. So I'd have parentheses -2, comma, 3, and since 3 is included in the solution set, I'd have a bracket. So that represents -2 is less than x and x is less than or equal to 3. Now, in algebra, this is the way we'd represent it. In calculus, we would replace that open circle around -2 with a parentheses, and we would replace that solid dot around 3 with a bracket, and then we'd represent everything in between. Now, there are also some other intervals that we want to discuss, and these are intervals that involve infinity. So if we have a to positive infinity, that consists of all values for x such that x is greater than a. So here, to represent x is greater than 2, it does not include 2, but everything which is greater than 2. And this continues indefinitely, so we say that this is the interval 2 to positive infinity. And here all these values for x are greater than 2. If we want to include the endpoint 2, then we simply throw an equal to under the inequality. And here I have x is greater than or equal to 2, so it does include 2 and everything greater than 2, and it continues indefinitely to what we call positive infinity. So the corresponding interval notation would be 2 to infinity. So the interval notation negative infinity to a consists of all values of x such that x is less than a. So x is less than 4 would be parentheses around the 4 and everything to the left of 4. X is less than 4. Here's 4. It wouldn't include 4. So in algebra we'd put an open circle, but in calculus we'd put a parentheses. And everything less than 4 would be to the left of 4. So the way you write the interval notation is you read it as it would occur on the number line from left to right. So this would be negative infinity to 4. And you never use a bracket on the same side that you have in infinity, because infinity is a concept. It's not a real number. It doesn't stop. It continues indefinitely. In other words, it decreases without bound. X can become infinitely negative. And again, the difference between this example and the one here is now, in addition to x being less than -1, it can be equal to -1. So it includes -1. So it includes -1 and all values which are less than -1. So again, the values for x decrease without Brown. They become infinitely negative. But in this case, it also includes -1. So to write the interval notation, this would be -infinity, -1. Never use a bracket on the same side that you have in infinity, but it does include -1, so I use a bracket around -1. And the last one that I do not have illustrated here would be the interval from -infinity to +infinity, which basically means that x is an element of the real numbers. X can be any real number from a -infinity to +infinity. So those are the 9 intervals that we will be demonstrating as we progress in this particular course. We will encounter absolute values quite often in calculus, so we need to know how to solve problems involving absolute value. So the first thing we're going to look at is absolute value and equality. So the absolute value of some real quantity q being greater than, or equal to, equal to some real number, some non-negative real number r, means the following. It means that q is equal to r, or q is equal to the opposite of r. There are two solutions, just like the absolute value of x equal to 4. X can be equal to 4 because the absolute value of 4 is 4, or x could be equal to -4 because the absolute value of -4 is also 4. So anytime you're working with an equality involving absolute value, there should be two solutions. So suppose I want to solve the absolute value of 2x minus 4 is equal to 6. Well, what I have to do is apply this definition. And it says the absolute value of some quantity, here the quantity is 2x minus 4, is equal to some non-negative real number. My non-negative real number is 6. Means that I can remove the absolute value symbols and say that the quantity q, 2x minus 4, is equal to the real number r, which is 6, or remove the absolute value symbols and say the quantity, which is 2x minus 4, is equal to the opposite of that real number. So that would be -6. So there are two solutions here. So adding 4 to both sides, I have 2x is equal to 10. Divide both sides by 2, and I have x is equal to 5. And so, of course, 5 is the solution. Check it out. 2 times 5 is 10. 10 minus 4 is +6. The absolute value of +6 is 6. But that's not the only solution, because I have another one. The absolute value of some quantity q is equal to r means you can remove the absolute value symbols and say that the quantity inside is equal to the real number r, or remove the absolute value symbols and say that what's inside the quantity q is equal to the opposite of r. So I also have to solve this as well. So I have, adding 4 to both sides, I have 2x is equal to -6 plus 4, which is -2. Divide both sides by 2, and I have x is equal to -1. -1 works in this equation as well. 2 times a -1 is -2. -2 subtract 4 is -6. Absolute value of -6 is 6. So be careful here. Apply this definition in order to solve a problem where the absolute value of some quantity q is equal to some non-negative real number r. There are two solutions, and here's how you find those two solutions. You remove what's in parentheses and say that that quantity is equal to the non-negative real number r, or you remove the absolute value symbols and say that it's equal to the opposite of r. The next thing we're defining is the absolute value of some quantity q being less than some non-negative real number r. And again, you're going to have to learn these definitions. The absolute value of some quantity q being less than some real number r means that q is less than r and at the same time greater than minus r. So if I ask you to solve the inequality, the absolute value of 2x minus 10 is less than 6, then this is your quantity q, and this is your real number r. So, applying the definition, the absolute value of some quantity q being less than some real number r means that that quantity q, which is 2x minus 10, is less than the real number r, which is 6, but greater than the opposite of r, which is negative 6. So here what you have to do is solve this inequality for x. Now the connective here is applied to be and, so this is 2x minus 10 is less than 6, and at the same time 2x minus 10 has to be greater than negative 6. So adding 10 to all three parts, to isolate the x, we have 2x is less than 16, and 2x is greater than 4. Now dividing all parts by 2, we see that x is less than 8, but greater than 2. Now this is our set notation, but remember in the last section we discussed interval notation, so I want you to write this using interval notation. So x is found on the open interval from 2 to 8. So x can be anything between 2 and 8, but not including 2 and 8. So any value for x along this interval should satisfy this inequality. The absolute value of 2x minus 10 is less than 6. For example, let's try 3. 3 is in this interval. 2 times 3 is 6. 6 minus 10 is negative 4. Absolute value of negative 4 is 4, and 4 is less than 6. Likewise, 7. 2 times 7 is 14. 14 minus 10 is 4. And the absolute value of positive 4 is 4, which is less than 6. Now, any value outside this interval on either side should not satisfy this inequality. It should not work because I do not have them included in the solution set. For example, if x is 9, 2 times 9 is 18. 18 minus 10 is 8. The absolute value of positive 8 is 8, and 8 is not less than 6. So 9 is not a solution. And likewise, if I were to use, say, 0, 0 is not in the solution set. 2 times 0 is 0. 0 minus 10 is negative 10. Absolute value of negative 10 is 10, and 10 is not less than 6. So 0 is not in the solution set. It will not work. We're also going to look at what it means for the absolute value of some quantity to be greater than some real number r. And again, you'll just have to learn the definitions here. So the absolute value of some quantity is greater than r means that that quantity is less than the opposite of r, or, and here the connective is or, in the less than case, the connective is and. It's implied and. But with a greater than case, and notice I emphasize that, the connective is or. So the absolute value of some quantity being greater than some non-negative real number r means that q is less than the opposite of r, or q is greater than r. So if I ask you to solve the absolute value of 2x minus 10 is greater than 6, then I have to apply this definition. What does it mean for the absolute value of some quantity be greater than some non-negative real number r? It means you can remove the absolute value symbols and say that the quantity inside, which is 2x minus 10, is less than the opposite of r, which is negative 6, or you remove the absolute value symbols and say that quantity inside, which is q, which is 2x minus 10, is greater than some real number r, which in this case is 6. And you solve each one of these. So again, if I add 10 to both sides, I get 2x is less than 4, which means x is less than 2, or add 10 to both sides here, I get 2x is greater than 16, or x is greater than 8. Now, you cannot write these as we did the inequality case. You have to write them as two separate inequalities because the connective here is understood to be and. You cannot write this together as one inequality with three parts because it makes no sense. Because x cannot be greater than 8 and at the same time less than 2. So what we have to do here is take the union, which is what OR means, of the two solution sets. So using our interval notation, x is less than 2 means that x decreases without bound. So that's negative infinity to 2. OR means union, and x is greater than 8 means that x increases without bound, 8 to positive infinity. So any value for x along these two intervals satisfies this inequality. For example, just choose one here. Say 0. 0 is a good value here. 0 is on the interval from negative infinity to 2. If I plug 0 in here, this gives me negative 10. The absolute value of negative 10 is 10, and 10 is greater than 6. Choose a value for x on this interval. Say 9. 2 times 9 is 18. 18 minus 10 is 8. Absolute value of 8 is 8, and 8 is greater than 6. So it works for any value of x along this interval or any value of x along this interval. So what you have to do is just memorize your definitions for absolute value of some quantity q being equal to some real number r, the absolute value of some quantity q being less than r, and the absolute value of some quantity q being greater than some real number r. Know what each of those means and how you find the total solution. Do not just list a partial solution. In this section, we're going to solve higher order inequalities. And by higher order, I mean inequalities of degree 2 or greater. The inequalities that we have been solving have been linear inequalities, where the exponential power for the unknown was simply 1. So here we're going to solve x squared minus 2x is greater than 8. So what we need to do is first of all begin by transposing one side such that one side of the inequality is equal to 0. So in order to do that, I'm going to subtract 8 from both sides. Then, if you remember, one of the easiest ways to solve quadratic equations, this is quadratic, it's a second degree equation, is to factor. So now we'll see if I can factor this. So the factors of the quadratic term are x and x. The sign of the constant term is minus, so that tells me I have unlike signs, one's plus, one's minus. So I got to choose the factors of 8 such that the sum of the outer and inner product gives me the linear term, which is minus 2x. So this is going to have to be 4, and this is going to have to be 2. So what I have here is the product of two creatures being greater than 0. So if the product of two creatures is greater than 0, that means that the product of these two must be positive. If the quantity is greater than 0, then that means it's positive. Well, how do I multiply two creatures together and get something which is positive. Well, that means either they're both positive, because a positive times a positive gives me a positive, or they're both negative. A negative times a negative will also give me a positive. So that means that this quantity is positive, and at the same time this quantity must be positive, so that the product of the two gives me something which is greater than 0, which is positive. Or this quantity is negative, and at the same time this quantity is negative, so that the product of the two, negative times negative, will give me a positive. So I have two cases to consider. Case 1. Both quantities are positive. That means x plus 2 would have to be greater than 0, and at the same time x minus 4 would have to be greater than 0, because a positive times a positive would give me a positive, which is something greater than 0. So that means x would have to be greater than negative 2, and at the same time x would have to be greater than 4. Now, the connective here is and. Both conditions must be satisfied at the same time. So x would have to be greater than negative 2, and at the same time x would have to be greater than 4. So where are both conditions met? Where the two overlap. So in order for both of these conditions to be met at the same time, in order for x plus 2 to be greater than 0, at the same time x minus 4 has to be greater than 0, then that means that x would have to be greater than 4. So the solution to this particular case would be 4 to positive infinity. Now just think about it. Any number that's greater than 4 is automatically greater than negative 2. Now, these values in between negative 2 and 4 would make the first factor positive, but would not make the second factor positive. So we'd have a positive times a negative, and a positive times a negative is a negative, and not greater than 0. So this is case 1. Case 2. Again, if I multiply a negative and a negative, that would give me a positive, which is something greater than 0. So in case 2, x plus 2 must be less than 0, and at the same time, x minus 4 must be less than 0. If something's negative, then it's less than 0. If this is negative, and at the same time this is negative, then the product of the two would be positive. So that means x would have to be less than negative 2, and at the same time x would have to be less than 4. Again, and means take the intersection, or means take the union. So if I look at these two on the number line, I have x is less than negative 2, which would look like this, and x is less than 4 would look like this. So what value satisfies both inequalities at the same time? These values, where they overlap. So the solution to this case would be negative infinity to negative 2. X would have to be less than negative 2. And again, any value for x is less than negative 2 is automatically less than 4. So the total solution to this inequality, x squared minus 2x minus 8 is greater than 0, would be negative infinity to negative 2 union 4 to positive infinity. And you can check this out by substituting values on this interval into the inequality here, taking the product and determining whether you get a positive or a negative. For example, if x is negative 4, negative 4 plus 2 is negative 2, and negative 4 minus 4 is negative 8, and negative times a negative is a positive. Take a value for x along this interval, say 5. If x is 5, that gives you 7. If x is 5 here, that gives you 1. And 7 times 1 is 7, and that's greater than 0. Now, any value in between would not satisfy this inequality. For example, 0 is not in the solution set. If I plug 0 in for x, that gives me positive 2 here and a negative 4 there, and 2 times a negative 4 is a negative 8, which is not greater than 0. Likewise, if I had x plus 2 times x minus 4 is less than 0. Well, then that means that the product has to be negative. So how do I get two negatives? A negative and a positive, or a positive and a negative. Because if you multiply these two, that gives you a negative. If you multiply these two, that gives you a negative. So if I switch the order of the inequality here and say this is less than 0, then I'd have two cases to consider. A negative and a positive, which means that x plus 2 would be negative. Anything that's negative is less than 0. And at the same time, x minus 4 would have to be positive. Anything that's positive is greater than 0. So I have a negative. X plus 2 is less than 0, means it's negative. And x plus 4 is greater than 0, means that it is positive. Well, that's one case. So that means that x is less than negative 2, and at the same time, x would have to be greater than 4. Now, if you look at this on the number line, x is less than negative 2 looks like this, and x is greater than 4 looks like this. Now remember, both of these conditions have to be satisfied at the same time. Well, they do not intersect. So the solution to case 1 would be the empty set, because x cannot be less than negative 2 and at the same time greater than 4. Now look at case 2. Case 2. The first factor could be positive and the second factor can be negative. In other words, we're just flip-flopping these two. So what does it mean for something to be positive? That means that it has to be greater than 0. And what does it mean for something to be negative? It means that it has to be less than 0. So here I get x is greater than negative 2 and x is less than 4. So if you look at the solution set here, negative 2, these are the values for x which is greater than negative 2. These are the values for x which are less than 4. Where do they overlap? In the middle. So the solution to case 2 is negative 2, 4. So any value for x along this interval will satisfy this inequality. But any value outside this interval will not satisfy this inequality. We're still looking at solving higher order inequalities. If I were to multiply these three binomials together, I would wind up with a inequality of order 3, because x times x times x would be x cubed. Now here I want the product of these three binomials to be greater than 0. So I want the product of these three to be positive. So how can I multiply three creatures and get a positive? This is positive, this would be positive, this would be positive. The product would be positive. Remember, something that's greater than 0 is positive. Well, that's not the only way. The first product could be negative, the second could be negative, and the third could be positive, which would give me a positive. Or I could have a negative times a positive times a negative, which would give me a positive. Or I could have a positive times a negative, which would give me a positive. So there would be 4 cases to consider. So I'd have to actually work each individual case and combine the solutions of all 4 in order to find the values for x for which the product of these 3 binomials would be greater than 0. And that would be a very time-consuming and tedious process. So we need a better method. We need a better method. And there is a better method, and it's called the critical point method. So using the critical point method, solving higher degree order inequalities, the first thing you need to do is make sure that one side of the inequality is equal to 0. And here that's already been done for us. And the next thing is determine all values for the unknown that will make the product equal to 0. So here, if x is equal to 4, then I get 0. Here, if x is equal to -2, I get 0. Here, if x is equal to -6, I get 0. So these are called your critical points. These are your critical values. Those are the values for x, which makes the product equal to 0. Now, if you're not sure how to get those, just take each factor and set it equal to 0. And that's how you get your critical points. Okay, so actually this is +6 here. Alright, so my critical points are 4, -2, and +6. So these are my critical points. Now these values divide the number line into intervals for which the product remains constant. So what you need to do now is construct a number line and place these values on the number line, not in the order that I found them, but in the order they would appear on left to right on the number line. So I'd have -2, I would have 4, and I would have +6. Now what I'm saying here is that these values divide the number line into intervals for which the product of these three creatures remain constant. So my intervals on the number line will be -∞ to -2, -2 to 4, 4 to 6, and 6 to +∞. So now what I need to do is to determine the sign of the product of these three creatures along each interval by choosing a value on each interval and substituting in for x in each of these three factors. So for example, choose a value on this interval. Say x equal to -3. And now I don't need to necessarily keep up with the product. What I need to do is to keep up with the sign of each one of the factors. So if I plug -3 in for x here, that gives me -6, and -6 minus 8 is a negative. So the first factor would be a negative along this particular interval. If I plug -3 in for x here, that will give me a -1. And again, I'm not interested in the value themselves, I'm just interested in the sign. And if I plug -3 in for x here, that would give me -9, subtract 18, which is a negative. So the product of those three would give me a negative. So for any value of x along this interval, the product of these three creatures would be negative. That's what I mean by these values divide the number line into intervals for which the product remains constant. So any value for x along this particular interval from -∞ to -2 would make the product of these three creatures negative. So now choose a value along this interval. There's a nice one in here, 0. So if x is equal to 0, and I plug 0 in there, that would give me a -8. If I plug 0 in there, that gives me a +2. If I plug 0 in there, that would give me a -18. But the product of the three, negative times positive times negative, would be positive. So for any value of x on this interval, the product of these three creatures would be positive. Then I do the same thing for this particular interval. Choose a value for x along this interval. Say x equal to 5. And again, I'm not necessarily interested in the product itself. What I'm really interested in is the sign of the product. So if x is 5, that's 10 minus 8, which is a +2. If x is 5, that gives me +7. And if x is 5, that's 15 minus 18, which is a negative. So the product of these three would give me a negative for any value of x along this interval. Now, choose a value for x along this interval. Say x equal to 7. Plug 7 in for x here. That's 14 minus 8, which is a +6. If you plug in 7 here, that gives you +9. Again, I'm not interested in the value itself. I'm just interested in the sign of each one of the factors. So 3 times 7 is 21. 21 minus 18 is positive 3. So the product of these three creatures along for any value of x along this interval would be positive. So now what I do is I select the intervals that satisfy the given condition. The given condition is I want the product of these three to be greater than 0, which means positive. So where is the product of these three positive? The product of these three are positive along this interval and along this interval. So the solution to this inequality would be all values of x between negative 2 and 4 union all values for x from 6 to positive infinity. So there is the solution using the critical point method. And of course we could have solved the other two quadratic inequalities that we looked at earlier by using the critical point method as well. So again, to kind of review solving higher order inequalities using the critical point method, the first thing that you need to do is make sure that one side of the inequality is 0. Then you need to determine all the values for x that will make the product equal to 0. And these are what we call your critical points or your critical values. They divide the number line into intervals for which the sign of the product will remain constant. So what you need to do is locate each one of those on the number line, not in the order that you found them necessarily, but in the order that they would appear on the number line from left to right. Then you need to determine the sign of the product by taking a value along each interval and substitute it in for x, and to determine whether the product will be negative or positive for each one of those values along each one of your intervals. Once you've done that, then you select the intervals that satisfy the given condition. The given condition here was that I wanted the product of these three to be greater than 0, which means I want the product to be positive. And these are the two intervals which will make the product positive.